Hello everyone and welcome once again to Captain Goodspeed Maths. I'm Joe, if you're new around here, and today we are going to be discussing equations of motion as part of the new spec for OCR FSMQ. The learning objective today is to understand how and when to use the equations of motion and be aware of where they are derived from. So, first of all, welcome to the world of mechanics. Might not be so wonderful, but hey ho, I'm going to call it wonderful. The wonderful world of mathematics. The place where we assume illogical things just so the maths will work. Today we're going to be talking about objects moving in straight lines with constant acceleration. For example, a car travelling down a straight road. So there he is there, going down a straight road. Look at him. He's very happy about that. We could be asked loads of things: his initial speed, his final speed, his acceleration, the distance he's moving, the time it takes him. You get the idea. We can be asked a lot of things about this. But the good news is we have some formulas of uniform acceleration that will help us to work out all these different things. So we've got v equals u plus at, s equals ut plus a half at squared, and v squared equals u squared plus 2as. You can see that from that we can work out v, we can work out u, we can work out a, we can work out t, and we can work out s. So they are the only three formulas you will need to learn. You may see in textbooks and on other videos there are a couple of other formulas to do with it. Learn those three and learn how to rearrange them, and you know, the job's done really. So learn those three, commit them to memory. They will be invaluable in your exam. But what do all these letters mean? Well, S is displacement, i.e. A distance in a certain direction, so a bit of physics coming into it. We've got U, which is the initial velocity, your initial speed between the time frame that we're looking. So when we were looking at that car, he was stopped, so his initial velocity was 0. Now V is the final velocity. So think about that car. If I said, right, I want to know his time right in the middle. So we would say, well, his initial speed is still 0. By the middle, I'm not so sure. How much time passed between that, and then maybe I can work it out. A is the acceleration, and T is the time taken. How do you remember all that? Think of it as SUVAT and try to learn the formulas. You'll learn them through practice, so there are tons of examples online. Look for old Mechanics 1 A-level papers. There will be plenty of those questions to try. So let's do a little example then, just to secure it really. A car moves from rest to a velocity of 10 meters per second in 4 seconds. Calculate the acceleration of the car and the distance travelled in this time. Comment on the displacement. So let's have a little look then. So we list our variables. So we've got SUVAT along the top, and then we ask ourselves, right, what have we been given? So a car moves from rest, so that is our initial velocity. Our initial velocity is going to be 0 because he starts at rest. He starts stopped. He is not moving. His speed is 0. Then it says to a velocity of 10 meters per second. Okay, so that must be his final velocity. He is moving at 10 meters per second at the end of this story. We're then told in 4 seconds. So that must be the time. So there you go. So we've got 3 things. We want to calculate the acceleration of the car and the distance travelled in this time. So they are the 2 things that we want to know. So think about the formulas. What are we given and what do we want to find? So these were the 3 formulas that I told you to learn. V equals u plus at, s equals ut plus a half at squared, v squared equals u squared plus 2as. So we've been given u, v and t, so I'm thinking that first equation is going to be a pretty good candidate for working out what a is. So we want to find out the acceleration, which is a, first. We're given the initial velocity u, final velocity v, and the time taken t. Anyone spot which formula has all of these in? Well, I gave you a little subtle hint before. V equals u plus at. So this is the formula we shall use. So let's do it then. So apply the formula. V equals u plus at. Sub in the numbers. And we get 10 equals 0 plus 4a. Rearrange. and we get 4a equals 10, so a is 2.5 meters per second squared. Remember your units of acceleration from physics. So there we go, we've got part A done. Let's go. Now we want the distance travelled, so we're going to have to use a different formula. We've got v, we've got u, we've got a. You could have used s equals ut plus a half at squared because you've got a and you've got t and u. So you could have used that one. I prefer having less variables, but there's different ways to do this, and the good thing is you'll get exactly the same answer. So I chose to use v squared equals u squared plus 2as. So rearrange it for s. Well, I haven't quite done that yet. I'm just putting in the numbers. So v squared is 100, 10 squared is 100, equals u squared 0 plus 2 times 2.5 times s. And then we rearrange it and we get s equals 20 because 100 divided by 5, because 2 times 2.5 is 5. 100 divided by 5 is 20, so he travels 20 meters. So comment on the displacement, because we've worked out the distance travelled. Comment on the displacement. Since the car's not changed direction, displacement and distance are the same. So remember, displacement, the definition of that is the amount of distance travelled in a certain direction. Anyway, a train passes a signal doing 72 kilometers per hour. The driver applies the brakes and it stops within 150 meters. Find the acceleration of the train. So a couple of little curveballs in here. List the variables. So we've got S, U, V, A, T, SUVAT. Read the question. So we've got a train passes a signal doing 72 kilometers an hour. So I think that's going to be our initial speed, because that's the start of the story. For some reason I put 150 in first, but that's another thing from the question. Now then, I've put 20 in for the initial velocity, but it said 72 in the question. Well, we'll come to that in a second. It comes to a stop within 150 meters, so its final velocity this time, the end of the story, it's come to a stop, it's come to 0. And t is, we don't know yet. We want to find the deceleration of the train. So we cannot work in kilometers an hour. We must swap to meters per second. That's why it's 20, because we need to convert from 72 kilometers an hour to meters per second. So 72 kilometers an hour means 72,000 meters in 360 seconds. So we divide the two and we get 20 meters per second. Hopefully that makes sense. So just be careful of that in an exam. I'd be quite surprised if they did it to you, but they're well within their rights, so make sure you read the question and convert if necessary. You're going to just have to think logically in this exam, and that's what's going to get you through it. So 20 meters per second is the initial speed. We want to find out the deceleration. Choose a formula with S, U, V, and A. So we don't even want to think about time this time. So v squared equals u squared plus 2as, s equals ut plus a half at squared, v equals u plus at. Which one of those formulas do you think that we're going to be choosing? Well done to anybody who thought this one. V squared equals u squared plus 2as. So apply the formula, v squared equals u squared plus 2as. Then substitute in your numbers. So you've got 0 equals 400 plus 2 times a times 150. And then rearrange, so you get a equals minus 4 over 3 meters per second squared. It's a deceleration, so it's a negative acceleration. I guess technically the deceleration is 4 over 3 meters per second squared, but it's a negative acceleration. I'm pretty sure you would get the marks either way, as long as you specified that that was what the acceleration was. And that is that. A negative acceleration signifies deceleration, i.e. losing speed. So that is where we're going to leave it for today. If you found it helpful, make sure you leave a like. Remember, all these lessons are uploaded to the Google Drive, so you can go through them at your own pace. And also, make sure you let me know down in the comments anything I can do to improve in the future. And thank you very much for watching. Subscribe for more FSMQ videos. Remember, all of the FSMQ stuff is in a playlist if you want to watch it all. And very best of luck with your exam.